For today's lesson, let's start with this situation. A school's hallway is to be tiled. The school engineer estimates that 5 workers can finish tiling it for 25 days. But what if the school director requests to expedite the work and wants that the job will be done for any of these days? 21 days, 14 days, and 17 days. Now, with this, how many workers will be needed? If each worker is paid 250 each, how much will be the labor cost? If you are the school director, into how many days of work is more practical to choose? Then why? These questions will be answered by our next lesson on inverse variations. For our first learning targets we have, I can identify the independent and dependent variables in a given situation. Then the second one is, I can tell whether the quantities are directly or indirectly related to each other. So may I request all of you to open your book on page 219. Okay, you're going to tell whether the quantities are directly or inversely related to each other, in which the first step is for you to do is identify first the independent and dependent variables. So let's start with item number 1. The side of a square is related to its perimeter. What is our independent variable? So we have here for this item, the side of the square is the independent variable and the perimeter is the dependent variable. Okay. If we are going to increase the length of the side of a square, will the perimeter of the square also increase? Yes, the perimeter will also increase. That is why the relationship between the two quantities is direct, or they are directly related. How about item number 2? The number of people sharing the pizza is related to the size of the slice each gets. I'll be giving you a few seconds to think of the independent and dependent variable. So, the number of people sharing the pizza is the independent variable, and the result would be the size of the slice. Okay. If there are many people sharing the pizza, okay, what will be the size of the slice look like? Will it be bigger or smaller? Of course, if you have plenty to share, then the size of the pizza that each gets is smaller. So notice that the direction of the independent and dependent variable is not the same, so they are inversely related. Item number 3. The age of the used car is related to the price the owner can get if he sells it. So these are the age of the used car is the independent variable and the price is the dependent variable. So as the number say the age is the as the age of the car is, or as the car gets older by years, okay, its price of course decreases. Okay? So we have they are inversely related. The time to read a book to the number of pages it has. Okay? So what will be our independent variable? Our independent variable is the number of pages. Then the dependent variable, the result, we have the time, that is our dependent variable. If you have plenty of pages, then you need more time to read it. So that is directly related. Next, the distance driven is related to the amount of gas left in the tank. Okay. So we have here, this is our independent variable. If you drive farther, then the amount of gas left in your tank would be, of course, lesser. Okay? So, they are inversely related. Next. How about number 6? The time a candle is used relates to the remaining length of the candle. Okay, the time is our independent variable. When you make use of a candle for a longer period of time, then of course the length would be smaller. Okay? So we have inversely related. They are inversely related. How about number 7? The number of days a tank of water lasts is related to the number of people in the household. The number of days a tank of water lasts is related to the number of people in the household. So this is our dependent variable. This is our independent variable. So mean to say, if you have plenty of people who will be using the water, then obviously we have fewer amount of water left in the tank as days go by. So they are inversely related. Next, number 8. The number of steps you need to walk 20 meters depend on the length of your step. Okay, so the length of your step is our independent variable. And for our dependent variable, the number of steps you need to take. So, if the length of your step is longer, okay, of course, the number of steps that you need to take to walk 20 meters, of course, would be lesser. Okay? So that is still inversely related. The amount of remaining ink in your pen is related to the number of hours it has been used. Okay? So the number of hours we make use of the pen, say we make use of it for a longer period of time, the remaining amount also would decrease. So as you can see, the directions are not the same, so we have inversely related. How about the last one? The water bill is related to the number of cubic meters of water consumed. Okay. So, our independent variable is the number of cubic meters of water consumed. If we have a higher number of cubic meters of water consumed, the water bill would be, of course, bigger. So they have, both independent and dependent variable have the same direction, so they are directly related. So why is this our first lesson? This is our first lesson simply because if you know how to identify the independent variable as well as the dependent variable and know their relationship, you can easily answer worded or real life problems. Okay? Now, in direct variation, we dealt with table of values in which a table of values that model direct variation was translated into an equation. This time, we'll do the same on inverse variation. So we have separate learning targets for this. We have, I can translate a table of values that model inverse variation into an equation. Then the second one, I can solve problems involving inverse variation. So what is an inverse or indirect variation? The phrase y varies inversely as x or y is inversely proportional to x means that as x gets bigger, y gets smaller or vice versa. In other words, the directions of the independent and dependent variables are not the same. So we have as one goes up, the other goes down, or as the independent variable goes down, the dependent variable goes up. This concept can be translated as y is equal to k over x, where, just like the direct variation, x is our independent variable, y is our dependent variable, and k is our constant. Now, what do you think is the equation to be used in determining the constant k? Would it still be the same as that of direct variation? Of course not. Okay? So we can derive it from this equation. Y is equal to k over x, What we need is only k, so we get the cross products, okay? Remember that when dealing with fractions, the easiest way to do it is get the cross products. Remember this, that the denominator of any whole number is 1. So y times x, or that's xy, equals 1 times k is k. That is why the constant is determined by the equation x times y. If the constant is not desired, we can make use of this equation, x sub 1 times y sub 1 equals x sub 2 times y sub 2. Now, let's have a comparison of the two variations that we have already discussed. We have direct and inverse. In direct variation, we have y is directly proportional to x, or y is directly, y varies directly as x. It is translated as y equals kx, whereas in inverse variation, y varies inversely as x, or y is inversely proportional to x, is translated like this. So in direct variation, we have the multiplication of the constant and the independent variable, while in the inverse, we have the division of the constant and the independent variable. How do we get k? K in direct variation is the quotient of y over x, whereas in inverse variation, it's the product of x and y. Okay? So remember that inverse variation is different from direct variation. Now let us look into how you can derive the equation of inverse variation given its table of values. Of course, you need to understand this part so you can solve the problem I have presented to you at the beginning of this video. Again, a table of values is what we call a numerical model. Okay? So given here a table of values, we're going to observe the values from top to bottom, and then we're going to determine whether this one illustrates a direct variation or say inverse variation. Okay? If it illustrates an inverse variation, then we're going to write its equation. So in writing the equation, what do we need to know first? We need to know first the constant. Okay. So we have here 1 going down, 7, x increases. Okay. Then we have here y 3 going to 0, it decreases. Okay, let us take a look at its constant. Okay, so let's go back here. We have pen. Okay, so let's determine now the value of the constant. So we have here, this one increases, this one decreases. So the constant is, you're going to get the product of x and y. So 1 times 3 is 3. 3 times 1 is 3. 5 times 0.6 is 3. And 7 times 0.43 is still 3. So the constant here is 3, and as what we can see, the relationship that involves between the two variables is inverse. And how do we write the equation? We make use of y equals kx as our standard equation, just replace our k. So we have y is equal to, our constant is 3, so we have y over 3x is the equation that models this given table of values. For our next table of values, okay, we'll do the same. We're going to observe the movement of x and y. So from top to bottom, so we have 5 going to 20. So we have the value of x increases. And for y, we have 3.40 going to 3.08. Notice that it decreases. So it's time for us to determine the constant. So we get the product of x and y. So we have 5 times 3.4 is equal to 17. We have 10 times 3.20. That's 32. Okay. Now look at these two products. They are not the same, so need not continue this part. So we don't have constant here. Okay, this is not anymore applicable, and of course, even the equation. Okay, so this is not an inverse variation. Okay, let's move on to the next set of table of values. Okay, so we have here 12 going to 3, that is the value of x decreases. How about y? You have 2.2 down to zero point 0.8, so we have increases. Let's check its constant. If they are all the same, if not the same, then we cannot write any equation. So how do we determine, get the product now? So we have, use your calculator, you have 12 times 0.2083 equals 2.5, 2.5, because that's 2.4996, so it can be rounded off to 2.5. Then we have 9 times 0.2778, still 2.5, rounded to 2.5. Then we have 6 times 0.4167. We have still 2.5. And for the last one, 3 times 0.8333, that is still 2.5. Notice that the products of multiplying the x's and y's are the same. Okay, so we have now the constant is 2.5. We can say now that the variation modeled is inverse. Then for the equation, our standard equation for inverse variation is y is equal to k over x. So we have now y, replace k with 2.5 over x. Okay? So this table of values is modeled also by y is equal to 2.5 over x. And for the last one, okay, let's observe first the movement of x and y. So 3 going to 12. So we have the value of x increases. The value of y also increases. So we don't need to determine the 3 here because the instruction is if it illustrates an inverse variation, it should be inverse variation here. Okay? We're going to write the equation. Okay, sige. Gawin na lang natin to. Kasi nga, anyway, we're done with direct variation, so I think you can answer this. Tingnan natin kung direct variation nga ba to. So you have 3 times 15 is 45. No, in direct variation, we should not be multiplying the x and y. So we have y over x. 15 divided by 3 is 5. 30 divided by 6 is 5. 45 divided by 9 is 5. And 60 divided by 12 is 5. So the constant here is 5. And this is not inverse. Instead, this is direct. And the equation is y is equal to kx. So we have y is equal to 5x. Okay? So again, the movement of x and y will tell us whether the table of values would model an inverse variation or a direct variation. Okay? Then, okay, it's time for you to work. Open your book on page 212 to 213. Answer activity number 9, skills practice. Now, I will be giving you 5 minutes to do this, okay? Now, prepare yourselves. You may use your calculator to aid you in your solving. So, kindly pause this video for a while. And then, when done, kindly play it again. Now, be honest. Do not automatically play the video to view the answer. Okay? So, everybody, pause the video. Let us now check your work for item number 1. Okay, let's observe from top to bottom. 4 going to 16 as the value of x increases. The value of y decreases. So this might be an inverse variation. Why did I say might? Okay. Bakit ko sinabing might? Kasi maaring hindi pa siya maging inverse kapag napatunayan nating hindi magkapareho ang constant. Nagiging inverse lamang kapag pareho lahat ang value ng constant. Okay? Let us now check the constant, okay, by multiplying x and y. So we have 4 times 1.75 equals 7. Okay. How about 8 times 0.875? That is still 7. You have 14 times, zero point 0.5. That is still 7. Then we have 16 times 0.4375. That is still 7. Now, we have shown that the values of k are the same. So, we have our constant is 7. So, this is inverse. Okay? The equation now is y is equal to 7 over x. Okay? Saan, ma'am? Saan galing yung y is equal to 7 over x? Again, for inverse variation, our standard equation is y is equal to k over x. How about for item number 2? As the value of x here, 25 going to 10, decreases, okay? The value of y, 3.2 going to 3.7, increases. Okay. Let us find out whether this table of values really models an inverse variation by the constant. Okay. Multiply the x and y here. So 25 times 3.2. So that is 80. Then we have 20 times 3.335. So we have 67. Now notice that these two products are not the same. So we can't have a constant here. So need not answer variation and equation here. Okay? So this is not inverse. Next, for item number 3, 16 going to 4, that is decreasing or decreases. 22 going to 10, that is decreasing also. So obviously, this is not inverse, but this can be a direct variation. Let's find out if it's really direct variation by looking into the constant. Okay, obviously kapag direct, we cannot use this one. Instead, we're going to make use of k is equal to y over x. Okay, so we have here 22 divided by 16 is equal to 1.375. 1.375. How about 18 divided by 12? We have 1.5. And the last one daw, 14 divided by 8. That is 1.75. Notice that the quotients are not the same. So this is neither direct nor inverse. Okay? So we cannot write anything here for constant, type of variation, and equation. So this is neither direct nor inverse. Okay? Next, for number 4. Let's observe 6 going to 24. It increases. 0.6 going to 0.1, so decreases. This can be an inverse variation. Let's verify using the value of the constant. So we have here 6 times 0.67, 667. So we have 4. You have 12 times 0.333. Okay, rounded to 4. That's 3.996. So it's still 4. You have 18 times 0.2222. That's 3.996 or rounded to 4. Then we have 24 times 0.1667, that's still 4. So, our constant is 4. We can now say that the variation modeled is inverse, and our equation based from y equals k over x, we have y is equal to 4 over x. Okay? So, did you get it now? Okay, so very good. Now, I want you to answer this part, okay, for a few minutes, maybe 1 minute lang, 1 minute maybe, okay? Then we will check it before having the next part of this lesson. Okay, pause this video for a while and then play it after answering. Let's check. Okay, supply the words or phrases or symbols that will make each statement true. I learned that in direct variation, to get the value of the constant k, I have to divide, we're going to divide y to x. Or in symbols, k is equal to y over x. In inverse variation, to get the value of k, I have to multiply x and y. Or in symbols, we have k is equal to x times y. If a relationship follows the pattern as x increases, y also increases, and vice versa, but the constants are not the same, then the relationship shown is not direct. Okay. To make it direct, the constants must be the same. If our relationship follows the pattern as x increases, y decreases, but the constants are not the same, then the relationship shown is not inverse. Okay? Inverse. So that's it. Let us now illustrate this variation using the relationship between speed and time when traveling. Say from Cotabato, you go to Davao with a distance of 244 kilometers. This is your average speed, 40 kilometers, 60 kilometers per hour, 80 kph, and 120 kph. But you don't know how, but you don't know that time, okay? Time of, or say, the time to be consumed in traveling. For 40 kilometers per hour, you'll just be traveling Davao for 366 minutes or 6 hours and 6 minutes. If you're going to use an average speed of 60 kilometers per hour, so we have 244 minutes or 4 hours and 4 minutes. And if you're going to use an average of 80 kilometers per hour, you'll just arrive in Davao within 3 hours. But what if you travel using the speed of 120 kilometers per hour? Okay. So how many hours will you be consuming before arriving Davao? Okay. So what can we do? Okay. Notice, of course, first step is you look at the movement of x and y. Notice that as the speed increases, okay, the time needed to travel decreases. Okay. So what are we going to do? We can make use of the table of values I'm solving this. Okay. So first is determine the constant. Okay. Let's make use of these minutes to determine the constant. So you have multiply x and y. So you have 40 times 366 is equal to 14,640. How about the next pair? You have 60 times 244. Still 14,640. And the last one, we have 80 times 183. Still 14,640. So our constant is 14,640. So this table of values can be represented by y is equal to 14,640 over x. And this value of y here can be solved using this equation. So we have y is equal to 14,640 divided by our x, which is 120. Okay, let's compute. 14,640 divided by 120, and that is 122 minutes. And that's equivalent to how many hours? We have 2 hours, 2 hours, and 2 minutes. Okay. Now, kung ikaw itong nakasakay sa sasakyan, traveling an average of 120 kilometer per hour, gusto mo yan? Okay. Will this follow the traffic rules or not? Okay. What will happen if you drive an average speed of 120 kilometer per hour? Is this good? Of course not. You might be encountering accident when you drive at this speed. So I suggest that we drive within the speed limit of 60 to 80 maybe, but not on 100 kilometer per hour because we might be encountering accidents or problems in the road. Okay? So that's it. That's that's the advantage of making use of table of values and converting it into an equation so we can easily solve for the unknown quantity. In this case, we have time. Time it takes to travel Davao. Okay. Now let's go back to the problem presented at the start of this lesson. Okay, I think we can answer this one now. A school's hallways to be tiled again, the school engineer estimates that 5 workers can finish tiling it for 25 days. But what if the school director requests to expedite the work and wants that the job will be done for 21, 14, or 7 days? Okay. How many workers will be needed? So we can represent it using a table of values. Okay, for our independent variable, we have the number of workers, and for our dependent variable, we have the time to finish the job. Based on the problem, if we have 5 workers, they can finish the job for 25 days. But what if we have 6, 9, and 18, 6, 6, okay, I think I need to edit this part first. Okay, I have already edited that part. Okay, let us now determine the number of workers needed if the school director wants that the job will be done for 21 days, 14 days, and 7 days. Okay, so what is the first thing that we are going to do? We need to determine first the constant. Okay, okay. So obviously, if you have work problem, if we increase the number of workers, the time it takes to finish the job, of course, will decrease. So its constant is determined by multiplying x and y. So we multiply 5 times 25, so we have 125. Then we write the equation. Okay, so our equation now is y is equal to 125 over x. Okay, using this equation, we can now determine the number of workers. Our y here is 21, so we have 21 is equal to 125 over x. Okay, getting the cross products here, we have 21x is equal to 125. So, dividing both sides by 21, 21, x is equal to 125 divided by 21 is 5.95. But do we have a 5.95 heads? Of course, we cannot do that. We have to round up. We say round up regardless of the decimal point, we're going to add 1 to our whole number, so we have 6. So we need 6 persons to work if the school director wants that the job will be done by 21 days. How about 14 days? Okay? So we have here for 14 days, we have y is equal to 125 over x. Okay? So our y is 14 equals 125 over x. Get the cross product, so we have 14x is equal to, we have 1 times 125, so we have 125 over 14. So we have x is equal to 125 divided by 14 is equal to 8.92, then round up, or 9. So we need 9 workers. Next, and the last one for 7 days, okay, we have y is equal to 125 over x. Our y is 7, so we have 7 is equal to 125 over x. We get the cross products here, so we have 7 times x is 7x. Okay, this is understood to be 1. Guess the cross product. We have 1 times 125 here. Dividing both sides by 7. X now is equal to 125 divided by 7 is equal to 17.85. Then round up again. So we have 18. So we need 18 workers here. Okay? So how about item number 2? Let me erase this part first. I think you are getting it. Okay? So I need to clear this part here so I can solve for the next problem. Okay? The next problem is the labor cost. Okay. Okay. I think this space now is enough. Okay. So for item number 2, if each worker is paid 250 each, how much will be the labor cost? Okay. So still we'll be making use of this table. Okay. Let me project that. Okay. So the entries here are placed here. So we have the rate per day of each worker is 250. So to get the total labor cost, we're going to multiply all these 3 columns. The entries in the 3 columns. So we have 5 times 25 times 250. The labor cost would be 31,250. For this, we have 6 times 21 times 250 equals 31,500. Then we have here 9 times 14 times 250. That is still 31,500. And for the last one, 18 times 7 times 250, we have 31,500. Now observe the labor cost and the number of workers and the time to finish the job. If you are the school director, into how many days of work is more practical to choose, then why? If you are going to ask me, how about you, ma'am? Okay, my answer would be this. Okay? I will be requesting for the job to be finished for 7 days with 18 workers. Anyway, I will just be paying same amount of money. Okay? So, if I'm going to choose here 25 days than 7 days, the difference only is 250 pesos. So, this is very impractical to choose. And this is the wisest option. Okay? So, do you know now how engineers estimate the labor cost, the number of workers, and even the time to finish the job? Okay, if you become an engineer, this is what you're going to do. Okay? I hope you learned a lot from this lesson today. Let us go back to our learning targets. Okay? So for our learning targets, first learning targets here, okay? Reflect on this. If you cannot still confidently say these learning targets, then you view this, you watch this video again. Same is true with these learning targets. Okay? Okay? So I hope you can confidently say to yourself these learning targets. If you cannot, again, review the lessons, the video lessons here, and then don't hesitate to give me feedback in our chat room or in our messenger. Okay? So, see you in our next class. Goodbye.